Hello, in this lecture we'll find out the value of angle ADC using two different methods. In the drawing we have triangle ABC. We know that side AD equals to side BC. We also know that angle ABC equals to 30 degrees. Angle ACB, this angle equals to 100 degrees, and we want to find out the value of this angle ADC. So we will start with the first method, and we will define side AC as A, that is to say the length of side AC equals to A units, and we will define side BC as B, that is to say side BC equals to B units in its length, and I'll present to you a new law that is actually the law of sines. According to the law of sines, in any triangle, you can use the law of sines in any triangle, so I write down in any triangle. If we have triangle ABC, that could be any triangle. So this is triangle ABC. And we know that side BC equals to A units in its length. The angle here is equal to A degrees. Side AC equals to B units in its length, and this angle is B. And side AB equals to C units in its length, and this angle is angle C. So according to the law of sines, A over sine A equals to B over sine B, equals to C over sine C, so in any triangle, A over sine A equals to B over sine B equals to C over sine C. From this formula we will derive that A over sine A equals to B over sine B, so this is the law of sines. and we will implement the law of sines in our drawing. So I will draw triangle ABC, and we will implement the law of sines in triangle ABC. I will draw triangle ABC in a new page, and we will implement the law of sines in this triangle ABC. So here so this is triangle ABC. We know that AC equals to A, BC equals to B, we will define angle BAC as angle X. So in triangle ABC, we know that the sum of the angles must be equal to 180 degrees, that is to say 30 degrees plus 100 degrees. Plus this angle that is defined as angle X. In total, they must be equal to 180 degrees. Here we'll subtract 130 degrees from this equation, and we'll get that angle X equals to 180 degrees minus 130 degrees. It equals to 50 degrees. So we found out that angle X equals to 50 degrees, so we'll substitute angle X by 50 degrees. And we will implement the law of sines in this triangle ABC. According to the law of sines, A over sinus 30 degrees equals to B over sinus 50 degrees. So here we will divide this equation by B, and then we will multiply it by sinus 40 degrees, and we will get that according to equation number 1, A over B equals to sinus 30 degrees over sinus 50 degrees. I'll repeat again. According to equation number 1, we got that A over B equals to sinus 50 degrees over sinus, A over B equals to sinus 30 degrees over sinus 50 degrees. So in the next step, we will implement the law of sines in triangle ADC. This triangle ADC. So we know that angle CAB equals to 50 degrees. This angle equals to 50 degrees. Okay? So if we define angle DAB as theta, then angle DAC will be equal to 50 degrees minus theta, because of the fact that the sum of those two angles must be equal to 50 degrees. Okay, so I will copy triangle ADC in the new page, and we will implement the law of sines in this triangle, triangle ADC. So so this is triangle ADC, and according to what is given us in the question, AD equals to CB. AD equals to CB, but according to our definition, CB equals to B units. So we can write here that CB equals to B units according to our definition, and from this equation we will derive that AB equals to B. AD equals to B. From this equation we will derive that AB equals to B. So here AD equals to B. And from the drawing you can see that angle DAC equals to 50 degrees minus theta. So it is here 50 degrees minus theta. And we know that the sum of the angles in any triangle is equal to 180 degrees. So if we define this angle as angle Y, then we will get that angle Y plus 50 degrees minus theta plus 100 degrees must be equal to 180 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. Here we will subtract 100 degrees from this equation, and we will get that angle Y plus 50 degrees plus minus theta equals to 180 degrees minus 100 degrees is 80 degrees. Here we will subtract 50 degrees from this equation, and we will get that Y minus theta equals to 80 degrees minus 50 degrees is 30 degrees. So here we will add theta to this equation, and we will get that angle Y equals to 30 degrees plus theta. So we found out that angle Y equals to 30 degrees plus theta. So we can write here that angle Y equals to 30 degrees plus theta. Actually, this is the angle that we are looking for. So here we will implement the law of sines in this triangle, triangle ADC. So according to the law of sines, we will get that A over sine 30 degrees plus theta must be equal to B over sine 100 degrees. I'll repeat again. in triangle ADC, if we implement the law of sines, we will get that A over sine 30 degrees plus theta equals to B over sine 100 degrees. Here we will divide this equation number 2 by B, and then we will multiply it by sine 30 degrees plus theta, and we will get that A over B equals to sine 30 degrees plus theta over sine 100 degrees. So according to equation number 2, A over B equals to sine 30 degrees plus theta over sine 100 degrees. And we have already found out that according to equation number 1, A over B equals to sine 30 degrees over sine 50 degrees. So here we will create equation number 3 that states, according to equation number 3, A over B, according to equation number 1 here, must be equal to A over B according to equation number 2. Okay? Again, according to equation number 3, A over B according to equation number 1 must be equal to A over B according to equation number 2. So A over B according to equation number 1, it is actually sine 30 degrees over sine 50 degrees, and it must be equal to A over B according to equation number 2, and the A over B according to equation number 2 is sine 30 degrees plus theta over sine 100 degrees. Here we will cross multiply equation number 3, and we will get that sine 30 degrees times sine 100 degrees equals to sine 30 degrees plus theta times sine 50 degrees. Here, sine 30 degrees is 1 over 2. So I'll write it down. 1 over 2 times sine 100 degrees equals to sine 30 degrees plus theta times sine 50 degrees. Here we will use the trigonometric identity that states that sine 2 theta, sine 2a equals to 2 sine a cosine a. According to this trigonometric identity, we will get that here sine 100 degrees will be equal to 2 sine 50 degrees cosine 50 degrees. I repeat again. According to the trigonometric identity that sine 2a equals to 2 sine a cosine a, we will get that sine 100 degrees equals to 2 sine 50 degrees cosine 50 degrees. And it will be equal to sine 30 degrees plus theta times sine 50 degrees. So here in equation number 3 we have sine 50 degrees on both sides of equation number 3, so sine 50 degrees will get cancelled. And what is left from equation number 3 after we cancelled sine 50 degrees? What is left, it is actually cosine 50 degrees. Here 2 over 2 is 1, so 2 will get cancelled. Cosine 50 degrees equals to sine 30 degrees plus theta. And we have the trigonometric identity that states that cosine theta equals to sine 90 degrees minus theta. So according to this trigonometric identity, we will get that cosine 50 degrees equals to sine 90 degrees minus 50 degrees. That is to say, cosine 50 degrees equals to sine 40 degrees, because 90 degrees minus 50 degrees is 40 degrees. So we actually can substitute cosine 50 degrees in this equation, equation number 3, by sine 50 degrees because by sine 40 degrees because sine 40 degrees equals to cosine 50 degrees. So we will do it now, and we will get that in equation number 3 we will substitute cosine 50 degrees by sine 40 degrees. Sine 40 degrees will be equal to sine 30 degrees plus theta. So if sine 40 degrees equals to sine 30 degrees plus theta, it means that 40 degrees equals to 30 degrees plus theta. Here we will subtract 30 degrees from this equation, equation number 3, and we will get that angle theta equals to 40 degrees minus 30 degrees, that is to say angle theta equals to 10 degrees. So we found out that angle theta equals to 10 degrees. And here in our triangle we are looking for angle ADC. Angle ADC equals to 30 degrees plus theta, and theta equals to 10 degrees. So angle ADC will be equal to 30 degrees plus theta. Angle ADC equals to 30 degrees plus theta. and theta equals to 10 degrees. So angle ADC equals to 30 degrees plus 10 degrees. That is to say, angle ADC, that is actually angle 30 degrees plus theta equals to 40 degrees. So we found out that angle ADC, the angle that we are looking for, equals to 40 degrees. Okay? So here, angle ADC, the angle that we are looking for, is equal to 40 degrees. So we finished with the first method. In the next step, I will present to you how to find out the value of angle ADC according to the second method. So in the second method, we will do a construction. We will extend side BC by a straight line and from point A we will draw perpendicular to the extended BC. So this angle is a right angle, that is to say it equals to 90 degrees. And this angle, it is also a right angle. And we will define the intersection point between the perpendicular from point A and the extended BC as point E. And we know that AD equals to CB, and so we will define BC as B, BC equals to B, or okay, we will define BC as A, and we will define AC as B. According to what is given as the question, AD equals to CB, AD equals to CB, but CB is defined as A. According to our definition, CB equals to A. So from this equation, we will get that AD also equals to A. And we'll define AE as Y and CE as X. Okay, and we extended the straight line BC by a straight line, so BE will be still a straight line, and we know that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we define this angle as angle Y, then we know that the sum of the angles on the upper side of the straight line BE at point C must be equal to 180 degrees. That is to say 100 degrees plus angle Y must be equal to 180 degrees. Here we will subtract 100 degrees from this equation and we will get that angle y equals to 180 degrees minus 100 degrees is 80 degrees. So we found out that angle y is equal to 80 degrees. We'll substitute angle y by 80 degrees. And we will focus on the right triangle, triangle ACE. On the right triangle, triangle ACE, we know that tangents 80 degrees. I'll repeat again. On the right triangle, triangle ACE, tangents 80 degrees will be equal to AE over EC. I'll repeat again. On the right triangle, triangle ACE, tangents 80 degrees will be equal to AE over EC. But AE equals to y according to our definition. So we substitute AE by y. And EC equals to x according to our definition. So we substitute EC by x. And we get that tangents 80 degrees equals to y over x. We will multiply this equation number 1 by x, and we will get that y equals to x tangents 80 degrees. So we found out that according to equation number 1, y equals to x tangents 80 degrees. In the next step, we will focus on the right triangle, triangle ADE. On the right triangle, triangle ADE. First of all, we will define the angle that we are looking for, that is to say angle ADC as theta. And in the right triangle, triangle ADE, sinus theta equals to AE over AD. I'll repeat again. On the right triangle, triangle ADE, sinus theta equals to AE over AD. But AE equals to y. So we substitute A by y. And AD equals to A, so we substitute AD by A. So in conclusion, we will get that according to equation number 2, sinus theta equals to y over A. Here we will multiply equation number 2 by A, and then we will divide it by sinus theta, and we will get that A equals to y over sinus theta. found out that according to equation number 2, A equals to y over sinus theta. But according to equation number 1, y equals to x tangents 80 degrees. So we'll substitute y in equation number 2, this equation, by x tangents 80 degrees, and we will get that A equals to y, according to equation number 1, is x tangents 80 degrees over sinus theta. So we found out that according to equation number 2, A equals to x tangents 80 degrees over sinus theta, and according to equation number 1, y equals to x tangents 80 degrees. Okay, so in the next step we will focus on the right triangle, triangle ABE. On the right triangle, triangle ABE, we will get that sinus 30 degrees equals to AE over A tangents 30 degrees, tangents 30 degrees, tangents 30 degrees equals to AE over A over BE. I'll repeat again. In the right triangle, triangle ABE, in the right triangle, triangle ABE, tangents 30 degrees equals to AE over BE. AE equals to y according to our definition, so we'll substitute AE by y. And BE, you can see easily from the drawing that BE equals to A plus X. BE equals to A plus X. So we actually found out that according to equation number 3, tangents 30 degrees equals to y over A plus X, A plus X. We have the values of y in equation number 1 and the value of A in equation number 2. So we will substitute y by the value that we found in equation number 1, and we will substitute A by the value that we found in equation number 2. In this, we'll substitute those two variables in equation number 3 by the values that we found in equation number 1 and 2 for y and A. And we will get that tangents 30 degrees equals to y, and according to equation number 1, y equals to x tangents 80 degrees over A plus X. And A, according to equation number 2, equals to x tangents 80 degrees over sinus theta plus x. So here we will multiply x by sinus theta, and then we will divide it by sinus theta in order to have a common factor with this expression. So it will be plus x sinus theta over sinus theta. And here we will move sinus theta from the denominator to the numerator of this expression, and we will get that according to equation number 3, tangent 30 degrees equals to x tangent 80 degrees times sinus theta over x tangent 80 degrees plus x sinus theta. So here we have x in the numerator and we have x in the denominator. So x will get cancelled and we know that tangent 30 degrees is 1 over square root of 3, so we'll substitute tangent 30 degrees by 1 over square root of 3. It equals to tangent 80 degrees times sine theta over tangent 80 degrees plus sine theta. Here we will cross multiply equation number 3 and we will get that according to equation number 3 tangent 80 degrees plus sinus theta equals to square root of 3 times tangent 80 degrees times sine theta. So here we'll subtract sine theta from this equation, equation number 3, and we will get that according to equation number 3, tangent 80 degrees equals to square root of 3 times tangent 80 degrees sine theta minus sine theta. We will take sine theta as a common factor from this side of equation number 3 and we will get that tangent 80 degrees equals to, we took sine theta as a common factor on this side of the equation. So inside the brackets we will have from this expression what is left is square root of 3 times tangent 80 degrees. And what is left from minus sinus theta after we took sinus theta as a common factor from it, what is left, it is actually minus 1. Here we will divide this equation by square root of 3 tangent theta minus 1 and we will get that sinus theta equals to tangent 80 degrees over square root of 3 times tangent theta minus 1. Okay, I repeat again. We found out that sinus theta equals to tangent 80 degrees over square root of 3 times tangent theta minus 1. Here it is actually sinus 80 degrees. Sinus 80 degrees, so here we will have sinus 80 degrees minus 1. So here we will substitute tangents 80 degrees by sinus 80 degrees over cosine 80 degrees, and we will get that sine theta equals to tangents 80 degrees is sinus 80 degrees over cosine 80 degrees, all divided by square root of 3 times tangents 80 degrees is sine 80 degrees over cosine 80 degrees, and we'll substitute minus 1 by cosine 80 by minus cosine 80 degrees over cosine 80 degrees. And here we have cosine 80 degrees in the numerator and cosine 80 degrees in the denominator, so cosine 80 degrees will get cancelled. What is left from equation number 3 after we cancelled cosine 80 degrees? What is left here in this side we have sine theta. In the other side we have sine 80 degrees over square root of 3 times sine 80 degrees minus cosine 80 degrees. So here we will multiply the denominator by 2 and then we will divide it by 2. So we will get that sine theta equals to sinus 80 degrees over square root of 3 over 2 times sine 80 degrees. We divide it by 2, so we must also multiply it by 2, minus cosine 80 degrees over 2, and then here we multiply it by 2, so it is allowable to divide anything by 2 and multiply it by 2, we change nothing. So here we got that sinus theta equals to sinus 80 degrees over 2 times sinus 80 degrees. Square root of 3 over 2 is sinus 30 degrees. Minus cosine 80 degrees, and 1 over 2 is sine 30 degrees. We have the trigonometric identity that states that sine A minus B equals to sine A cosine B minus cosine A sine B. So according to this trigonometric identity, we will get that sine 30 degrees times sine 80 degrees times sine 30 degrees minus cosine 80 degrees times sine 30 degrees, it is actually equals to sine 30 degrees minus sine 80 degrees minus 30 degrees. Okay, and we will get that here sine theta equals to sine 80 degrees over 2, and this expression sine 80 degrees times sine times it is actually cosine 30 degrees, because square root of 3 over 2 is cosine 30 degrees. Again, square root of 3 over 2 is cosine 30 degrees. So here we have sine 30 degrees times cosine 30 degrees minus cosine 80 degrees minus times sine 30 degrees. That is identical to the trigonometric identity that sine A cosine B minus cosine A sine B equals to sine A minus B. So it will be equal to sine 80 degrees minus 30 degrees. So I write it down again. We actually got that according to equation number 3, sine theta equals to sine 80 degrees over 2 times sine 80 degrees minus 30 degrees again. We got this expression that sine theta equals to sine 80 degrees over 2 sine 80 degrees minus 30 degrees, because this expression sine 80 degrees times cosine 30 degrees minus cosine 80 degrees times sine 30 degrees equals to sine A minus B, according to the trigonometric identity that sine A cosine B minus cosine A sine B equals to sine A minus B. So it equals to sine A minus B, that is actually sine 80 degrees minus 30 degrees. And according to the trigonometric identity that sine 2A equals to 2 sine A cosine A, according to the trigonometric identity that states that sine 2A equals to 2 sine A cosine A, we will get that sine 80 degrees equals to 2 sine 40 degrees cosine 40 degrees, all divided by 2 sine 80 degrees minus 30 degrees is 50 degrees. And here 2 over 2 is 1, so 2 will get cancelled. So in conclusion, we got that sine theta equals to sine 40 degrees times cosine 40 degrees over sine 50 degrees. And we have the trigonometric identity that states that sine theta equals to cosine 90 degrees minus theta, So according to this trigonometric identity, we will get that sine 50 degrees equals to cosine 90 degrees minus 50 degrees. That is to say, sine 50 degrees equals to cosine 90 degrees minus 50 degrees is 40 degrees, so it is cosine 40 degrees. So we actually found out that sine 50 degrees equals to cosine 40 degrees. So we substitute sine 50 degrees in this equation, equation number 3, by cosine 40 degrees. And we will get that sine theta equals to sine 40 degrees times cosine 40 degrees. And I repeat again, we'll substitute sine 50 degrees by cosine 40 degrees according to this equation. Sine 40 degrees equals to cosine 40 degrees. So it is sine 50 degrees is cosine 40 degrees. So here we have cosine 40 degrees in the numerator and we have cosine 40 degrees in the denominator. So cosine 40 degrees will get cancelled. And we left only with sine theta that equals to sine 40 degrees. From this equation we will derive that theta equals to 40 degrees. Theta equals to 40 degrees. So here angle theta equals to 40 degrees. Here we got that angle theta equals to 40 degrees. The angle that we are looking for equals to 40 degrees. So we actually found out that angle theta, that is actually angle ADC, equals to 40 degrees. Angle ADC that equals to theta equals to 40 degrees. We finished with the second method. In the next step I will summarize the lecture. Actually we found out the value of angle theta in two different methods. In the first method, we use the law of sines. What is the law of sines? The law of sines states that in any triangle, if this is triangle ABC, that could be any triangle, side AB equals to C units, side AC equals to B units, and side BC equals to A units, then A over sine A equals to B over sine B equals to C over sine C. A over sine A equals to B over sine B equals to C over sine C. From this formula we will derive that A over sine A equals to B over sine B. And then I copied triangle ABC in a new page, and here this is triangle ABC. We know that angle ABC equals to 30 degrees, angle ACB equals to 100 degrees. So this is the missing angle. And we know that the sum of the angles in triangle ABC equals to 180 degrees. That is to say, the missing angle here, that is angle X, plus 30 degrees plus 100 degrees, must be equal to 180 degrees. We subtracted 130 degrees from this equation and we got that angle X equals to 50 degrees. So this angle is the missing angle equals to 50 degrees. Okay, and then we implemented the law of sines in this triangle ABC according to the law of sines. A over sinus 30 degrees equals to B over sinus 50 degrees. We divided this equation number 1 by B, and then we multiplied it by sine 30 degrees, and we got that A over B equals to sine 30 degrees over sine 50 degrees. So according to equation number 1, A over B equals to sine 30 degrees over sine 50 degrees. Then I copied triangle ADC in a new page, and we analyzed triangle ADC. Here this is triangle ADC, and we actually know that this angle ACD equals to 100 degrees, and we already found out that angle BAC equals to 50 degrees. So if we define angle BAD as theta, then angle DAC, this angle must be equal to 50 degrees minus theta, because in total angle BAC must be equal to 50 degrees. So if this angle is theta, this angle must be equal to 50 degrees minus theta. In order to complete the sum of those two angles to 50 degrees, this angle must be equal to 50 degrees minus theta. So we found out that this angle DAC equals to 50 degrees minus theta, this angle is 100 degrees, and this angle is the missing angle. So if we define this angle as y, then angle y plus this angle that is 50 degrees minus theta plus 100 degrees must be equal to 180 degrees. Then we subtracted 100 degrees from this equation, and we got that y plus 50 degrees minus theta equals to 80 degrees, because 180 degrees minus 100 degrees is 80 degrees. Then we subtracted 50 degrees from this equation, and we got that y minus angle theta equals to 50 degrees minus 80 degrees minus 50 degrees is 30 degrees. We added theta to this equation, and we found out that angle y, the angle that we are looking for, equals to 30 degrees plus theta. Okay? Then we implemented the law of sines in this triangle ADC. According to the law of sines, A over sinus 30 degrees over theta equals to B over sine 100 degrees. I'll repeat again. According to the law of sines in triangle ADC, A over sine 30 degrees plus theta equals to B over sine 100 degrees. Here we cross multiply this equation, we cross multiply this equation. We divided this equation by B, and then we multiplied by sine 30 degrees plus theta, and we got that A over B according to equation number 2 equals to sine 30 degrees plus theta over sine 180 degrees. That is according to equation number 2, but according to equation number 1, A over B equals to sinus 30 degrees over sine 50 degrees. So we created equation number 3 that states that A over B according to equation number 1 must be equal to A over B according to equation number 2. Okay, so and A over B according to equation number 1 is sine 30 degrees over sine 50 degrees, and A over B according to equation number 2 is sine 30 degrees plus theta over sine 100 degrees. Here we cross multiply this equation number 3, and we got that sine 30 degrees times sine 100 degrees equals to sine 30 degrees plus theta times sine 50 degrees. Sine 30 degrees is 1 over 2, so it is 1 over 2 times sine 100 degrees times sine 30 degrees plus theta times sine 50 degrees. We use the trigonometric identity that states that sine 2 theta equals to 2 sine theta cosine theta, and according to this trigonometric identity we get that the value of sine 100 degrees equals to 2 sine 50 degrees cosine 50 degrees. Yeah. So we have 1 over 2. From here we have 1 over 2, and sine theta according to the trigonometric identity equals to 2 sine 50 degrees cosine 50 degrees, and it equals to sine 30 degrees plus theta times sine 50 degrees. We have sine 50 degrees on both sides of equation number 3, so sine 50 degrees will get cancelled. And what is left from equation number 3 after we cancelled sine 50 degrees, what is left is in this side of the equation number 3 of cosine 50 degrees, that equals to sine 30 degrees plus theta. And according to the trigonometric identity that cosine theta equals to sine 90 degrees minus theta, we will get that cosine 50 degrees equals to sine 90 degrees minus 50 degrees. That is to say, cosine 50 degrees equals to sine 90 degrees minus 50 degrees is 40 degrees. So we found out that cosine 50 degrees equals to sine 40 degrees. So here, therefore we can substitute here sine, we can substitute cosine 50 degrees by sine 40 degrees in equation number 3. We have here cosine 50 degrees. Okay, we have cosine 50 degrees that equals to sine 30 degrees plus theta, so we can substitute cosine 50 degrees by sine 30 degrees according to this equation. So we substituted cosine 50 degrees by sine 40 degrees, and we got that sine 40 degrees equals to sine 30 degrees plus theta. That is to say 40 degrees equals to 30 degrees plus theta. We subtracted 30 degrees from this equation, and we got that angle theta equals to 10 degrees. Angle theta equals to 10 degrees. And so here angle theta equals to 10 degrees. Angle theta equals to 10 degrees, and angle ADC, here angle ADC equals to 30 degrees plus theta. Okay, angle ADC equals to 30 degrees plus theta, and theta equals to 10 degrees. Therefore, angle ADC equals to 30 degrees plus 10 degrees. That is to say, angle ADC equals to 40 degrees. So we found out that according to method 1, the first method, angle theta equals to 40 degrees. Then I presented to you how to find out the value of angle theta according to the second method. In the second method, we did a construction. We extended BC, we extended side BC by a straight line, and then from point A we drew perpendicular to the extended BC. We defined the intersection point between the perpendicular from point A and the extended BC as point E. So this angle is 90 degrees and this angle is 90 degrees. And we know that BE is a straight line. BE is a straight line. And we know that the sum of the angles on one side of a straight line must be equal to 180 degrees. So if we focus on the upper side of the straight line BE at point C, the sum of the angles must be equal to 180 degrees. That is to say, this angle that is 100 degrees plus this angle that is angle Y must be equal to 180 degrees. Angle 180 degrees plus angle Y must be equal to 180 degrees. We subtracted 100 degrees from this equation, and we got that angle Y equals to 180 degrees minus 100 degrees equals to 80 degrees. So we found out that the value of angle Y is 80 degrees. Then we focused on triangle ACE. On the right triangle ACE, we know that tangents 80 degrees equals to AE over CE. Tangents 80 degrees equals to AE over CE. A equals to y according to our definition, C equals to x according to our definition. So we found out that angle is 80 degrees equals to y over x. We multiplied this equation number 1 by x, and we got that angle that y equals to x times tangent 80 degrees. Then we focus on the right triangle ADE. We defined angle ADE, the angle that we are looking for is angle theta, and according so we know that sinus theta equals to tangent sinus theta equals to AE over AD. In triangle ADE, we know that sinus theta equals to AE over AD. A equals to y according to our definition, and AD equals to A. AD equals to A. So, in conclusion, we found out that sinus theta equals to y over A. Here we multiplied equation number 2 by A, and then we divided it by sinus theta, and we got that A equals to y over sinus theta. Okay, so, and according to equation number 1, y equals to x times 80 degrees, so we substitute y by x times 80 degrees over sinus theta. So in conclusion, we found out that A equals to x times 80 degrees over sinus theta, and according to equation number 1, y equals to x times 80 degrees. Then we focus on the right triangle ABE. In the right triangle ABE, tangents 30 degrees equals to AE over EB. Again, in the right triangle ABE, tangents 30 degrees equals to AE over BE. AE equals to y according to our definition, and BE, you can see easily from the drawing that BE equals to A plus x. BE equals to A plus x. So in conclusion, we found out that tangents 30 degrees equals to y over A plus x. Then we substituted y by x times 80 degrees, and we substituted A by x times 80 degrees over sine theta plus x. Here we have plus x. We multiplied x by sinus theta, and then we divided by sinus theta in order to have a common factor with this expression. Then we have here x in the numerator and x in the denominator, so x will get cancelled. And we know that tangent 30 degrees equals to 1 over square root of 3 units. So we substituted tangent 30 degrees by 1 over square root of 3 units. And here we have tangent 30 degrees times sine theta over tangent 30 degrees plus sine theta. Here we cross multiply this equation number 3, and we got that tangent 80 degrees plus sine x equals to square root of 3 times tangent 80 degrees times sine theta. Here we subtracted sine theta from this equation number 3, and we got that tangent 30 degrees equals to square root of 3 times tangent 30 degrees times sine theta minus sine theta. Here we took sine theta as a common factor from this side of equation number 3, and inside the brackets we have square root of 3 times tangents 80 degrees minus 1. So here we divided this equation number 3 by square root of 3 tangents 80 degrees minus 1, and we got that sinus theta equals to tangents 80 degrees over square root of 3 tangents 80 degrees minus 1. So sinus theta equals to, we substituted tangents 80 degrees by sine 80 degrees over cosine 80 degrees. So tangents 80 degrees equals to sine 80 degrees over cosine 80 degrees. And here also we have square root of 3 tangents 80 degrees. It is actually square root of 3 sine 80 degrees over cosine 80 degrees. And minus 1, we substituted that minus 1 by minus cosine 80 degrees over cosine 80 degrees. And here we have cosine 80 degrees in the numerator and cosine 80 degrees in the denominator, so cosine 80 degrees will get cancelled. And we have here sine, what is left after we cancel cosine 80 degrees is from equation number 3 is that sine theta equals to sine 80 degrees or square root of 3 times sine 80 degrees minus cosine 80 degrees. So we got that sine theta equals to sine 80 degrees. Here we multiplied the denominator by 2 and then we divide it by 2. So here square root of 3 over 2 times 2, and here cosine 80 degrees over 2 times 2. And here square root of 3 over 2 is actually cosine 30 degrees. We have also times sine 80 degrees. And 1 over 2 is sine 30 degrees. So here we have cosine 30 degrees times 30 degrees. And actually, according to the trigonometric identity, that sine A minus B equals to sine A times cosine B minus cosine A times sine B, we will get that this expression, sine 80 degrees times cosine 30 degrees minus cosine 80 degrees times sine 30 degrees equals to sine A minus B, when A is 80 degrees and B is 30 degrees. So we get from this expression sine 80 degrees minus 30 degrees. So here we have the expression. We substituted the previous expression by sine 80 degrees minus 30 degrees according to the trigonometric identity. So here we have sine theta equals to sine 80 degrees or 2 sine 80 degrees minus 30 degrees. Here 80 degrees minus 30 degrees is 50 degrees. And according to the trigonometric identity, that sine 2a equals to 2 sine a cosine a, we will get that sine 80 degrees equals to 2 sine 40 degrees cosine 40 degrees. And here we have 2 sine 50 degrees. So 2 over 2 is 1. So in conclusion, we got that sine theta equals to sine 40 degrees times cosine 40 degrees over sine 50 degrees. And according to the trigonometric identity, that sine theta equals to cosine 90 degrees minus theta, we will get that sine 50 degrees equals to cosine 90 degrees minus 50 degrees. Cosine 90 degrees minus 50 degrees is 40 degrees. So we found out that sine 50 degrees equals to cosine 40 degrees. So we can substitute sine 50 degrees in this equation number 3, by cosine 40 degrees. So we did it, and we got that sine theta equals to sine 40 degrees times cosine 40 degrees, and again we substituted sine 50 degrees in the denominator by cosine 40 degrees according to this equation. And here we have cosine 40 degrees in the numerator, and we have cosine 40 degrees in the denominator. So it will get cancelled, and we left only with sine theta that equals to sine 40 degrees. If sine theta equals to sine 40 degrees, it means that theta equals to 40 degrees. So we found out that the angle ADC, the angle that we are looking for, it is angle theta that equals to 40 degrees. So in both methods we found out that the value of this angle ADC that we are looking for, it equals to 40 degrees, okay? Angle ADC equals to 40 degrees in both methods. Okay, thank you very much.